take a look at number 1. We have a little warm-up just to kind of remember how to do this stuff. Okay, so if you needed to find f of negative 4, remember you would pick where negative 4 fits. Okay, well, so negative 4, would that be less than 0 or greater than 0? That'd be, negative 4 would be less than 0. So I'd take my negative 4, I'd plug into the top. So f of negative 4, I'd be plugging in here. So it'd be negative 4 plus 2 squared plus 1. Negative 4 plus 2, remember we're following PEMDAS, so parentheses first. Bless you. What's that? So minus 4 plus 2 gives us negative 2. And then negative 2 squared is negative 2 times negative 2, which is positive 4. 4 plus 1 is 5. Good. Okay, now let's say that I wanted to plug in f of 3. Then I would have to pick where 3 fits into my piecewise. So 3, is it less than 0 or greater than 0? Greater than, so I'd have to plug in here. So I'd have half of 3 plus 3. Okay, and then that one, half of 3 would be what as a decimal? 1.5. And 1.5 plus 3 is 4.5. Okay? Make sense? Remember doing this last week? A little bit? Okay, one next to it. Okay, we are plugging in 2 numbers again. First number is negative 1. Does negative 1 fit as less than 2 or greater than 2? Less than, so I'm going to take negative 1. I'm going to plug it in here. Negative 1 squared plus 4. Remember, you have to do your exponent first. So negative 1, when I square it, what do I get? Positive 1. But then I still have a negative in the front of that. So if it's 1, but with a negative in front, that's really a minus 1. Minus 1 plus 4 is 3. Same as 4 minus 1 if you just reverse the order. Okay, then for f of 6, where would I plug that guy in, top or bottom? 6 counts as greater than 2, so I'd be plugging in here. So it'd be negative a half of 6 minus 3. What's half of 6? 3. So then it's negative 3 minus 3 more.
So then that would be 6.
Negative 6. Good. Make sense?
So if it's negative for a plus, something is going down. But if it's negative minus something, up.
Yes. Like think about it. You borrow $3, then you borrow 3 more. Then you still owe me 6. Okay, now the other thing we're going to do before we get into our new stuff for today is we're going to review how to graph these. Some of y'all on your reviews, they looked a little weird. So let's come back to this guy right here. Okay, so which one is going to be my open and my closed hole for number 1? Top is going to be what? Okay, it's closed because it has the equal to on it. Okay, then the bottom is going to be open because it does not have it. Y'all remember doing this?
First one's quadratic.
Okay, so the first one's quadratic. I'm plugging in the number 0. So I'd have 0 plus 2 squared plus 1. 0 plus 2 is 2. What's 2 squared? 4 plus 1 is 5. So I'm going to go to 0, 5, and I'm going to put a closed circle on my graph. Then remember, my top equation is the shape of the top function. So if this is an x squared, what shape is x squared usually? It's a U shape, like this. Okay, but I have to figure out where its center is, where its vertex is. Good, so if I have a plus 2 here, that means I go to the left 2. Then up 1, that puts me here. And then I'm just going to draw my U in. But when I get to this dot, I have to stop, because 0 is when I switch from this equation to this equation. Good so far? Okay, now for our open circle, we're plugging in 0 here. What's half of 0? Half of 0 is 0. And then 0 plus 3 is 3. So put an open circle at 3. So it'd be half of 0 plus 3. 0 plus 3 is 3. Open circle at 3. And then I follow the shape of the bottom equation when I go to the right. So if it's a half x plus 3, that's going to be a straight line. Like that. That's a y equals mx plus b. So I begin at 3, and then what's my slope? 1/2. So it'd be up 1 over 2, up 1 over 2, up 1 over 2.
You want to the right, yeah.
Mm-hmm. Now, after I've graphed it, you can check your work and see if you did it right, right? If I want to know where I'm at -4, okay, look at your graph at -4. My graph could have been a little bit steeper. It should have gone through 5. Mine goes a little off to the side, but you get the idea. Okay? All right, take a look at number 2. Top or bottom, which one is going to be closed? Okay, on this one, the bottom is closed and the top is open. Remember, you're plugging in your breakpoint, so I'm plugging in 2. So I have -2 squared plus 4. Okay, remember, exponent comes first. What's 2 squared? 4. And then if I have a negative front, that's really a -4 plus 4. Where does my open circle go? How high? What y value? 0. Now, what's the x value? What did I plug in for x? 2. So I'm going to go to 2, open circle at 0. Now, from there, I have to follow the shape of the graph on the left. So if it's an x squared, what shape is that? Is it a line, a V, or a U?
A U.
It's a U. Which way does it open if it's got a negative in front?
The left.
It's a U that's going to open
Down.
down. Now, which way does the plus 4 shift it?
Up 4.
Up 4. Very good. So I'm going to start at 0, go up 4, then draw your U, opening down. We know it opens down because of the negative, and we know that the vertex is at +4 because of the plus 4. So it's going to go from my dot up to 4, then back down. Okay, let's find our closed circle. We're plugging in 2 here. So I want -1/2 of 2. And then -3. What is half of 2? Close. Half of 2 is 1, so I have -1 minus 3 more. Which is how low? -4. Close dot at -4. And then at -4, I have to follow the shape of whatever my bottom function is. If it's a half x minus 3, what is that? A line, a U, or a V?
Line.
That's a line. And what's my slope?
-1/2.
-1/2. So I'm going to start here, go down 1 over 2, down 1 over 2. So I'll start at that closed dot, and I'll go down 1 over 2, down 1 over 2, down 1 over 2. Now, if I were to graph that all the way back to the y-axis, where would it hit the y-axis at? Look at your equation. -1/2 x minus 3. It would have hit right here. Okay, but it doesn't because I have to stop that line before it gets there. Okay, we remember how to do piecewise?
So who?
That's what this is called, is a piecewise, where it's like 2 pieces of a graph. Okay, so come down to the bottom. We're going to look at a certain type of piecewise. It's called a step function. Okay, and basically a step function can look right here. It's a function that increases from one constant value to another. So what that means is that from -8, what is that symbol? That should be a less than. And that should be y'all fix that. So from -8 to -5, I'm at -2. That's this value right here. Notice I'm closed on one side, I'm open on the other side. Then from -5 to -2, I'm at a height of 1. So I have a hoi through 1. Okay, now let's do the domain for 4. How long am I at a height of 4? What's this x value? -2 till 4. And then should I make -2 open or close? Look at your graph. -2 at 4, though, is closed on the left, and open on the right. So closed on the left, open on the right. Okay, for my last little chunk, my last little hoy, how tall is it? What y value? 7. So put a 7 as your y value. And then how long is it at 7 from?
9.
From 4 here till 9 here. Should 4 be open or closed? Closed. 9 should be open. Okay, so it's just a function where it just kind of like weirdly jumps. Okay, the domain for this, how far to the left does my graph go? -8. How far to the right does it go? 9. So put -8 to 9. Now let's talk about why we don't have to break it up. If I broke it up, actually, I need to fix something on that. What do I need to fix? The way I wrote it.
The bracket on the -8.
-8 needs a bracket. Now, does 9 need a bracket as well? No, because 9 stayed open. Now, when I switch from each piece, even though negative, whatever this is here, 5, even though it's open here, there's another dot at -5. So I don't have to break it up. Then I come across to here, -2 would have been open, but there's another dot at a height, or at an x of -2. Then I come to here, that would have been open, but I have a closed one. So that's why you don't have to break it up into multiple chunks. Okay, now let's talk about the range. What's the lowest my graph goes? -2. What's the highest it goes? 7. But is there ever a point it's at -1? For your y's? No. Does it ever hit 0? Now it hits 1, but then does it ever hit 2? 3? 4? Yes. So when your function jumps like that, you're just going to list the y values. Because it's not from -2 to 7 and everywhere in between. It has these big gaps. So when you do your range for this, you're going to do your little bracket. Y within all real numbers. And then you're just going to list out the numbers that y is allowed to be. What's your lowest y value, we said?
-2.
Put a -2, comma. When's the next chunk of your graph? What y value? 1. What's your next one? 4, then 7. So -2, 1, 4, 7. But the reason you have to list them out, the reason you have to list them out like that is because it's skipping. You have those big gaps, okay? Now, just how to pick these. So f of -7, look at your graph. Where does -7 fit in my x's?
Oh, 4.
-7 fits between where? From -8 to -5. So what's my answer? -2. Okay, we're looking to see where it fits. Okay, now when I want -3, where does that fit?
-5 to 2.
-5 to -2, because it's a -3, right? So we'll go here, which means my answer is 1.
Oh, 1, yeah.
1. Okay, then when I move to 0, where does 0 fit between? -2 and 4. So what's the y value for that chunk? 4. And then for my last one on that row, I have it at 7. 7 fits here between 4 and 9. So my y value is also 7. Now, look right here, it says breakpoints. If you have a split in your graph, you have to pick the closed dot. Or if you like it better, the closed dot is going to be where the equal to is. So this is what I mean by that. If I want f of -5, I have to pick the one where equal to is on a -5. I'd have to pick here. That's where x is greater than or equal to. So I'd have to pick 1.
So for 4, it would be 7.
Very good. 4 up here doesn't have an equal to. 4 down here has an equal to. So I would have to pick 7. Okay, good question. Look at 9. Does 9 ever have a closed dot? No, then it would be undefined. Okay, and I'm going to put because there's no closed dot. Okay, or you could think about there's nowhere that 9 has an equal to. If you like looking at the equation part better, that's totally fine. Make sense? Good? Okay, turn over to the back. Okay, so we got one more like that. Okay, let's do our piecewise. For the first chunk, how low is it here? What's my y value? -3. Then put your little comma, and then I have to list how long it's there. So if I wanted to list this line chunk, how far does it go back? That's an arrow.
Infinity.
Negative infinity till when?
2.
2. So you'd go negative infinity until 2. Or, if you like it better, you can do x less than 2. It doesn't matter which way you want to do it. Usually they're written like this if it's piecewise. But if you prefer that, that's fine. Now, do we give it a bracket or parentheses?
A parenthesis.
Parentheses, which means that if I'm going to use a less than, I can't put it equal to, yeah? Okay, now for this chunk, what's my y value?
2.
2. And then what's my my x value going to be?
2 infinity.
Okay, you could do from 2 to infinity. Or, what could I put instead of a less than?
X greater than 2.
Greater than 2. And then since it keeps going and it has that little arrow, my graph keeps going forever and ever and ever. Okay, my domain. How far to the left does my graph go forever and ever and ever?
All in one.
Okay, well, careful. All the way to the left,
Uh,
all the way to the right, right? But this dot, does my graph ever touch 2?
no, because it's open.
No, it's open here. If it were closed here,
Yeah, it's
then it would fill it in. But since they're both open, you have to break your graph up. So your domain is from negative infinity to 2, then it doesn't touch 2, and then it keeps going, union from 2 to infinity. So because these guys are both open, I can't squish my whole domain together like I could on the last one. There's never a dot at 2, so I have to break it up into 2 chunks. Now, for my range, I'm going to put y within all real numbers. And then I'm going to list out the only y values that my graph appears at. My y value here was -3, and my y value here was 2. So it'd be -3, comma 2. Because I only have lines at specific values. They're not going through a bunch. Okay, now, if I wanted f of -20, what piece would that fit in? Is -20 less than 2 or greater than 2? Less than, so it'd be -3. What about f of 0? Where does that fit in? Less than 2 or greater than 2? 0 is less than 2, so it's -3. Okay, what about f of 2?
Wouldn't it be not undefined?
It's undefined because which one has an equal to on it? Neither one. Or there's no closed dot. If you like that better, that's okay too. Then last one, if I want f of 50, is that less than 2 or greater than 2? Greater. So that'd be 2. Make sense? Okay, last thing we have to talk about today, it's pretty easy, is the degree of a polynomial. So when you look at a graph, you can determine whether it's even or odd based on the graph. So it says the degree of a polynomial is determined by the value of the exponent on any given term. So look at all of these graphs of evens. What do you notice about the ends of the graph?
They don't get
Well, you can put arrows on there if you want them to continue. But what do you notice about the direction? They're either both going up or they're both going down. Okay, now go down a row, look at your odds. What do you notice about your ends on your odd graphs? One's down, one's up. One's up, one's down. Up, down, down, up. So when your polynomial is even, your ends will both be the same direction. So right here it says even degree polynomials with a positive coefficient, the ends both point towards infinity or up. If it has a negative leading coefficient, your graphs are going to both point towards negative infinity or down. So what that means is, let me put here, both ends of graph pointing same way. So for the first one, this is even, and it has a positive coefficient because they're going the same direction and the ends are up. For the second one, it's still even, but it has a negative leading coefficient because my ends are both pointed down. Make sense?
So up even.
Up is even, down is odd, just like you would probably kind of guess. Okay, now go down to the odds. Odd degree polynomials, your ends will be pointing opposite ways.
So it's up is in.
Okay, so let's talk about if it's positive, and you can even look at these graphs. For x cubed, that one's positive. Do you see how it goes down, then up? Okay, look at your leading coefficient here, though. What is it? And that one's up to down. Okay, then this one is negative. Which way does it go? Up to down. This one's positive. Which way does it go? Down to up. So when we fill in the blanks there, if it's a positive coefficient, it's from down to up. And then for a negative coefficient, it goes from up to down. So, real quick, I want you to do that part of your homework for me. You're just circling. Turn over your homework to the back side. Oh, here's something else. No? Oh, yeah. Thank you. Okay, look at number 5. We're just going to run through the top row. Okay, number 5, look at it. So I'm on the back of my homework. Which way are my ends going? Together or opposite? Opposite. Then circle odd. And then is it down to up or up to down? Down to up, which means it's positive or negative? Positive. So that is an odd with a positive coefficient. Okay, look at the second one. Are my ends together or opposite?
Together.
They're both pointed the same direction, so it's even. Okay, then are they both up or both down? Up, so it's positive. Okay, look at the third one. Last one we'll do together. Ends are together or opposite?
Opposite.
That makes it odd. And then is it going up to down or down to up?
Up to down.
From up to down means it's negative. Got it? Okay. All right. And then here, I don't know why these converted to that weird symbol, but just change those to this guy. Okay. Do y'all want help graphing number 3, or do you want a minute to try it? Oh yeah, you weren't even here. Okay, so for my first line, how low is it going to be? -5, where is it going to start? And when's it going to stop? So on your paper, you're going to do a dot at -5, -9, that'd be right here. It's going to go all the way until -3, and then we're going to end it with an open circle, just like that.
Oh, you go like.
So that is the y value, and then those are the x's. This is what you...
Yeah, that's the Y value, so -5.
Okay, so my next chunk, where's it going to go between what x's? -3 till 5, and how low is it? 3. So I'm going to start at 3 at -5, open or closed dot here,
Close.
closed, and then it's going to go all the way across, staying at 3 until when? 5. So I would do a closed dot at -3, 3, and then I'm going to keep going all the way until I get to 5, then I'm going to leave it open. My last chunk, how high is it?
8,
It's at a height of 8, and what are my x's I'm going between?
5.
5 till 9. Now this symbol again is a equal to. So how does this one end? Open or closed? Fix it though, because it's that weird little L is the equal to. So from 5 to 9, I'm at 8, which is here, and then I stay closed at 9. Do I have to break up my domain? Do I have any double opens? At this break, is either one of them closed? Okay, that one's closed. I don't have to break it up. What about here? Okay, that one's open, but that one's closed. So do I have to break it up? No. You'll go from -9 all the way until 9 with no breaks. Should the -9 be open or closed? -9 is closed. What about +9?
No, open. Well,
Closed. Because remember, on the other example we did in the notes, this end point was open. But on this one, it was closed. Okay, then your range. Y within all real numbers, which y's can it be? How low is my first chunk?
-5.
-5. How low is my next chunk? 3. How low is my last chunk?
8.
8. And then remember, when you're doing those middle values, you're picking where those numbers go between. Okay? So let's do -14 first. Where does that fit?
It don't fit nowhere.
It doesn't fit anywhere. Very good. -14 is not between -9 and -3. Not between -3 and 5. Not between 5 and 9. Then what do you put if it's not on the graph? Undefined. Okay, and then I'll put -14 not between any x values. Okay? What about -3? Where does that fit between?
The type? No, please.
Okay, -3 is open here, so where do I have to fit it in?
The equal to.
The middle two, where the equal to is. And at -3, what y value do I pick? 3. 0, where does 0 fit between? Top, middle, or bottom?
Middle.
Okay, 0 is between -3 and 5, so what y value do I pick? 3. One more like that, f of 6, where does 6 fit between?
8.
It's going to go in 8 because it's between 5 and 9. Then last one, f of 9, where do we put for that?
8.
8. That's going to go in the bottom chunk. Make sense? Cool. Okay, you have almost 20 minutes, so let's get your homework done. If you have any late work, show it to me today so that I can mark it off so I can type it into Focus for your progress report tomorrow.